this is the kind of like not specified to the example that I'm doing. So you essentially have some client interacting with this. This is the main part. So the point of the composite method, composite design pattern, is you can have these composite objects, right, which either contain other composite objects or leaves, right? So some sort of just like final thing. So the best way to understand this is like a folder, right? It's like a folder on your computer, right? Can hold like actual files. I'll just say that's a file, right? Or other folders, and those folders can hold files, right? And da 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 da. And we want to be able to say some operation is being used uniformly here, right? So I can call, get size. Like this is the example that the teacher did. So I'm not going to use this example as my actual code, but you can call something like get size on a folder, and it will just ask get size for all of its children. And so then so if you call get size on this, it'll get the size of this, it'll get the size of this, but calling get size on that folder will just, again, cause this to happen, right? So essentially, the point is you want to be able to call certain methods on objects, on leaves, and composite objects in the same way. You kind of don't really want to particularly care if they are composite objects or leaves, right? You just want to be able to do it. And this generic method 2 does that a little bit better. Less safe, but does it a little bit better. So there's that. Okay, so this is how we're going to code this one here. So the way it works, I don't think I made a client. I'm just going to check if I made a client. You don't have to have a client. Set. No, it looks like I did make a client because I don't see any main method here. Yeah, I made a client then. Let me just see my code. Is it? Oh yeah, I think it's called client composite. There you go. There it is. So the client is essentially just a class. Let me just do this here. So we have client composite, which is the one that I created, right? Which just has the main method. Right? So client composite. So we won't do the exact UML diagram for this, just to give you an this is just to give you an idea of what it looks like. So the client composite is using, right, a component abstract. So this is an abstract class, right, which I'm just going to call set component. Okay, and a set component is either going to be a number, right? So we're just going to imagine sets like math sets that either have numbers in them, right, or there are composites, which are just like like folders, which are just sets, right? So a set component is either a number or another set, and so a set, right, can contain either a number, multiple numbers, multiple sets, single set, doesn't matter. Contain some combination of set components. And so then I think at this point we do a little triangle here. Oops, let me just do it like this. Right, so we say like this, which is the aggregation relationship, which is to say that one set can have 0 to many set components, right? You can have 0 or many set components. And again, the client is really just here to interact with this. It's just to have some sort of access point here. This is where the main file is. That's the whole point. There's no main method in all this. So again, we're talking about, in this example, we're going to be talking about sets, like number sets. Like when I say sets, I mean like the discrete math sets that we do, like that. Okay, so let's go ahead and code this. So the way I do this, I'm just going to open up a new, I'll just open up a new file. So we'll start with the, let's see what we start with. So let's start with creating a set component, right? A set component. So a set component, and then the operation that I'm going to support through all of this, right? So again, we have to have some sort of operation. Operation that we're going to support through all of this is sum, right? Sum of some set component. So when you call the sum of the set component, if you call it on a set, it'll just add together all the numbers. If you call sum on a number, it'll just return itself, right? Because the sum of itself is itself. Okay, so I guess we'll start with set component, or we can start with number actually. Let's maybe start with the concrete one. So the two things that are going to be in this composition, right? So maybe let's start with that. So I'll start with a Java class, and it'll be called number. Okay. And it's part of the same package. So here it is. Okay, so in the number class, could you zoom in occasionally when you're on the code, please? Yeah. Sorry, did I? Let me open this up like this. So it's like this. If I forget, just remind me, and I will zoom in, of course. Okay, so a number, right, is going to be extending. So it extends set component, right? Because set component is the kind of like parent class for the numbers and the sets, right? But we'll deal with that in a second. It's an error, but it doesn't matter. So anyway, so there's going to be a private int number, right? Because a number has an actual value, which is, we'll just call it an integer for now. Right? And then I'm going to just make some sort of constructor for it so that we can create a number with some sort of value, right? So I just said int number, this dot number equals number. So there we go. Now we can create number objects that have some sort of particular value. But remember, we also want to have this, well, actually, for now, this is fine, but we can just leave it like this. This is pretty much all we would want to create in a number. We're going to add to this when we have to deal with what exactly is in a set component. But for now, this is just the basic outline of a number is just a number, like an int, and you can assign it by creating it through the constructor, a public constructor. Let's try set now, I think. Yeah, okay. Let's try set. So a set, again, we're going to add to all this code after, but I'm going to create a new object here. So live class. Okay, I'm going to call it a set. Set.java already exists. Why does set.java already exist? I mean, it does, of course, but oh, I'm in the wrong package here. If I go here and I say class and I say set, yes, there we go, we're good. Okay, it's just because I coded this out before, so it thinks I was in the wrong package there. Okay, so a set is just going to be an array list of set components. That's all it's going to be, right? So we need to import java.util.arraylist, okay? And I'm just going to create an array list. So a private array list, and it's only going to have set components, right? Oh, sorry, I'm going to zoom in so you can see set component. Okay, and we're gonna, actually, that's actually all we're gonna do here for now, right? Because when I create a set, that's when I want to make the actual array list. So what I'm gonna do is I'm just gonna make a constructor. So public set, and when I create the, sorry, I have to give it a name. So I called it elements. So what I'm gonna do now is just, say this is elements. When I create the thing, when I create the actual class, an instance of the class, we're just gonna say elements equals new array list, and we only want to have set components going into it. Yes, that looks right to me. Just comparing to what I said here. Oh, and I guess I need to have that here too. Does the composite need to extend the component? I always forget which name means what, so let me look back at the diagram. The composite needs to extend the component. Yes, the composite needs to extend the component because the composite is made up of components. So let me write this here, right? The composite, this is the composite, right? This is the composite. So the composite there's an aggregation relationship saying that the composite is made up of set components, which are either other sets, other composites, or numbers, which is comparing up here, it's composite and leads, right? But in the case we have here, yeah, no problem. Okay, so carrying on with this one here. So, it's telling me that I have an issue. I have set components, right? That's not something I've done yet. So I've just created like what a set is. A set is an array list. A number object is just an integer. But now let's actually go ahead and create what a set component is, right? So we've done the basic outline of what these two are. We're going to edit them because they have to inherit some methods from here. But now let's go ahead and say what a set component is. So I'm going to create, I'm going to go actually right click right here, live code, new, wait, shouldn't set extend set component then? Yes, it should. Set. Yes, it should. Thank you. Yes. Extends. Set component. There you go. So now I'm going to make a new Java class. This Java class is going to be set component, right? And this is going to be an abstract class. So set component, yeah. So this is going to be a public abstract class set component. So we don't want to ever create a set component. The only thing that actually exists is a number or a set, right? But in the set component, right, we are going to just have a bunch of abstract methods in here. So the first abstract method you want to have in your set component, it doesn't matter first, but like the first one we're going to put is the one that's supported, right? So the sum method is uniformly supported by all set components, right? So I'm going to make that. I'm going to say public abstract, not void, int, is it int? Int sum. Okay, so I'm going to just say that all set components should have the ability to be called upon, the sum command. And then there is, some other things we need, right? Just dealing with these kinds of things. So here, okay, what I'm trying to say is we have these children managing classes is what they're called. Children managing, sorry, they shouldn't say classes. Children managing methods. I'm going to fix that after. Children managing methods, right? And so adding a component, removing a component, getting a component, or getting a component count, these are all just things that seem to be just basically you include it when you're talking about when you're using the composite design pattern. You include these managing classes. I don't actually know if it's like a right or wrong requirement to have them, but I think you should just put them. So we'll do that. We will include these. These should be in the set component. Let me just put it here, right? So we need to have all of the things I just mentioned. We need to have a public abstract void, which is add component, which takes in a set component comp, I'll just call it. We need to have a public abstract void remove component, remove component, okay, which will also take in a set component comp, okay. And then I need to have a public abstract set component. So this one is the get component method. This is really just returning an it's not returning an index. This is returning the set component, which is at index I, right? And public final one, abstract int get component, okay, which takes in get component count. So this just returns how many components we have in this thing. Coding, yes, that's true. We are coding here, computer engineers. So here's our abstract. These are all the things, and remember, these methods can only be called upon by let me find it, by the composite. Now technically they literally can be called upon by the leaves, but you're not supposed to let that happen, which is why this is an unsafe way of doing it. Now you can also put these methods only in here, right, and make them not abstract, but then you have to what's the word, you have to force them to be the data type. Late binding. You have to, there's another word that I'm trying to say, I forget now, but you have to force them to be a certain data type, the composites. Cast them, you have to typecast them to be a composite before you do it. You have to typecast the component to be a composite. Okay, but we'll do it like this because it's easier to do it like this. So here we have, that's it. That's the entirety of our set component. So a set component is just a class that supports all of these methods here. Now, this is the one that's uniformly supported, and these are called the children managing method. I keep saying classes, methods. Is question? No? Someone just got their mic on. Check your mics, everybody. Check your mics. Okay. I'll just turn them down. Okay. So put it like this. Okay. Do you want to? Oh, Christian, this looks hard. Thank you, Manuel. I don't know if Manuel's still here, but thank you, Manuel.
I am.
Oh, hey, how's it going?
I wanted to join you guys.
Learn some coding?
So,
Switch back to computer?
No. I gotta do back shit, but
I understand.
Nice seeing it.
Yeah.
Bye, everyone. Good luck. I love you, Adam.
Bye, Manuel. Love you too. Okay. So. Okay, so
tired as hell.
He did sound tired. It sounds like a mechanical engineering problem. Yeah.
I was about to say that's a you problem.
Yeah. Ethan asked a question: why can't we put children managing methods in the set class? Children managing methods. We can put children managing methods in the set class. We can't put them in the leaf class. Leaf class. It doesn't make sense to put children managing methods in the leaf class, right? Because they're like the leaf is just like a number. It doesn't make sense to add a component to a number, right? Or get a component from a number. Why are we putting them in the component abstract class instead of just the set class? The reason we do this is because I can then say, when I declare a variable which is of type component, right? I can then just say component dot add component or something like that, right? If I didn't have this here, I would have to say typecast that variable from component to composite or to set, right? And then call add component. But if I have it in both, if I have it in the abstract class and I have it in the composite, then I don't have to do any typecasting. Okay, I don't have to do any typecasting. But it runs the risk of you by accident calling add component on a leaf. But like if you know, like that's not gonna happen by accident. But you can't have an object of type component because it's an abstract class. Yeah, so you're gonna declare the pointer to be pointing to the reference variable to be referencing a component, right? But that's actually gonna be either a composite or a leaf, either a set or a number, right? So I'm gonna declare variables that are set components, but they're actually going to be either sets or numbers. And I'm gonna want to be able to call upon them, these children managing classes. Right? Just call upon the set component, children managing class. Right, that's the idea. Okay, so let's continue here. That's it. That's all for set component. That's completely done. We have our children managing classes and the actual one supported method. Let's go back now. Of course, the other pieces of the code aren't working anymore, right? So number, let's see what the issue is. Number is not abstract and does not override get component, set component, da 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 da. So the way you do this here is, you can either make it throw an error, or generally you can just make it return nothing, right? So that's kind of, and this is how like she actually did it in the code. Like I'm not just making this up. This is how she did it in the lecture. Is if you have a situation like this where number now has to have some sort of concrete implementation of add component, remove component, get component count, all that. But again, it doesn't actually make sense to call that on a leaf, on a number. So what you do is you just make them, you'll see what I mean. Public, like, so let's put an implementation that doesn't do anything. Add component, right? This will take in a set component comp, right? And it will do nothing. There. That's it. You just make it do nothing. And so now, we're satisfying the fact that this is inheriting from set component, but it doesn't actually do anything when you say add component. So in another way to say this is like, you just like the user shouldn't call add component, remove component on a number, because it just like, we don't make any promises. Like that's like the procedural abstraction thing. Like we don't make any promises about what it's going to do if you do this stuff. So it doesn't matter what I choose here. So I'm just going to say public void remove component. Okay. It's also going to take in a set component comp. It will also do nothing. Public, what does this return? Set component get component. This will take in an int I, right? This will, it has to return something, so it's going to return void, return null. Oh, why did that not work? I have to put a semicolon. There we go. And then finally, public int get component count, takes in nothing. It just returns 0. There you go. So we just have to put these here because it has to satisfy that it's extending from set component, but they don't actually do anything because it doesn't make sense to call these methods on a leaf, on a number. We still have an underline, and that's because I need to implement the sum, right? You need to be able to call sum on a number, and so it has to has the same like matching signature. So it's going to be what was it in set component? It was public int sum. Okay, so public int sum. Okay, you just call upon this. What it's going to return, right? Return is just itself, right? The not the self as in like a variable itself, as in like a class of itself, but literally like the number that's being held within this number class. Just return that. That's the sum. Okay, and this is now done with the number class. This is what the number class is going to look like. So now let's move on to set. Right, let's finish up set here. So set will actually have implementations of the add component, remove component, get component count, those child managing classes, because this is where you actually have the array list. Right? Let's first put in the sum, right? So this is the method that has to be supported uniformly. So let's put in public int sum, right? And this is an important part of the composite design pattern, right? Important, I don't know, important. So is this sum method? Well, okay, so it doesn't have to be exactly sum, right? But the point is this, the idea that you have, this is the method that's being uniformly supported, right? So it has to be written like this. You have to call that method for all of the children of the, or sorry, for all of the elements of this array list. So in case of a sum here, I'm going to say int, I want to keep track of something. So I'm going to say int sum equals 0, right? I'm going to say for set component element in elements, right? So for every element in elements, I want to say sum plus equals element dot sum, and then finally I want to return sum. So what this code is going to do is it's going to just declare a variable sum as 0, and then for every element in this array list, it's going to call element dot sum. It's going to get the sum, and we're going to add that to this running tally here, right? And at the end, it's going to be it's going to just be a number. And we can do this because these elements are all set components. And since they all inherit from this set component abstract class, they all have a sum method, right? And this means I can call sum on them. So when it is a set, when we're calling sum on a set, it's just going to do this method again, but within that new set, right? Within that new composite. But if it's calling this on just a number, that's just going to return the number because that's what we want to add. We just want to return the value of the number. So the sum method is now done, right? And that's the uniform. Yeah, it is like recursion, absolutely, right? So when I call, if I have, actually I'll draw a picture when we get to the main method, and I'll show you there that you're right. It is exactly like recursion. Okay, so numbers done. I just got to fix set. So set is just not quite done because I need to actually override those abstract things. So let me actually put here. I think I'm supposed to put override. I don't think it actually makes any difference, but maybe I'm wrong. I don't know. Let me put override here as well. And I guess these should all have overrides before them, but whatever. It's fine. I won't do that. Okay, so now let's actually override the child managing classes. So what were our child managing classes? How about instead of flipping back and forth, I'll just split screen this. There you go. So our child managing class, oh, that's the next example. Where are we? There we go, set. So the first one we need is add component. Public void add component, okay? And this is going to take in a set component comp as to match the abstract signature. So we're going to say override this, okay? And add component, well, all it is you just say elements dot add comp. That's it. It's an array list. It's very easy to work with. Next one, public void remove component. It's going to take in a set component comp, and what it's going to do, elements dot remove comp. There we go. That's it. Is that it? Let me make sure that's it. Yes, it is. Then, oh, sorry, lowercase r though. I don't know why I made that capital. Now we want to do the same thing, but for get component. So this is going to be a public set component, and it's called get component. So this is going to take in some integer I, and it's just going to return the ith element from the array list. So I'm just going to say elements dot return elements dot get. Is that the code? Elements dot get. Yeah. Finally, we have a public int get component count. Okay, and this is going to return an int, so it's just going to return the length of the array list. So we're going to return elements dot size, and that returns the length of the array list there. Okay, so we now have a set class that has all of the overriding of the child managing classes, and then we also have it overriding the sum method. We have what's it called, a constructor. We have a number which overrides all these child managing classes because it has to, but it doesn't actually do anything, and it shouldn't be called. These methods should not be called. It overrides the sum by just returning itself, and you can create a number with some sort of value. And then finally we have a set component, which is this all it inherits from. So the last thing to do to actually see if this works is to make a new Java class and call it client composite. Okay, and make sure it's in the same package, right? Client composite. It doesn't have to be composite, but whatever. Just some other client. But again, it has to be in the same package. So from here, we're just, I don't need this anymore. Let me just put this back there. Oh no, that's not what I meant to do. From this client composite now, I just have some sort of main file. So I'll just show you the main that I put together. So there's the main I put together. We want to, someone's got their mic on again. Dream28, I think you got your mic on. Dream28. No luck? Okay, everybody just turn him down, I guess. Do I have the ability to mute him? I don't have the ability to mute him, so there we go. Okay, so let's here's the main method I put together. So sorry, Discord's being weird. Let me open up the chat again. What chat were we saying things in? It was in 528. Yeah. Okay. So I have 528 open. Set component C1. I'm going to create a set component, which is a set. I'm going to create a set component, which is a set, different sets. Okay. I'm going to how about this? Let me just take a screenshot of this quickly, and then just draw what this looks like. So we have a set C1, okay, which contains, well, okay, I don't know what it contains yet. Then add component to C1, I'm going to add C2, which is another set, right? I'm going to add C2, which is another set there. Okay? To C1, I'm also going to add C3, which is a number, which is the number 5. Okay, so C3 is a number 5. They're all set components though, right? Because the array list in the set can only hold set components. So set component C4 is another number, which is the number 3. So I'm going to add that to C2. So I'm going to add the number 3. And then to C2, I'm also going to add the number 4. Right? So this is kind of the structure here. So if I call sum on C1, it should be 5 plus the sum of this, which is 3 plus 4. So very much recursion, right? You just call it on this here. When it gets to here, it'll just return like a base case. And here, when it gets to here, it's just going to call itself again until it gets to a base case. And the base case is just a number, not having a set anymore. So anyways, we should get 12 out of this when I add all this together. So let's try it. I will run my client composite. And the sum of all, it's very small, but the sum of all the elements is 12. So there we go. It did in fact work. And the benefit of this, right, is now that you can call c1.sum, right, c1.sum, and you have this kind of structure where you can build sets within each other and ask certain questions about them, and like that. That's it for composite. Any questions about the composite design pattern while I open up the next bit of code? Next one we're doing is state. So any questions, let me know. Okay, sounds like we're good. So let's move on to our state pattern. Okay, sorry, there's 2 questions. I mean, there's 2 people typing, so go ahead and type first. So the state, I need state. And that's everything I need. Yeah, that should be it. can I go over the class diagram again? I'm a bit confused by the abstraction. Class diagram like this, like how this works here. That's what you mean by class diagram? That's a class diagram. So I think that's what you mean. Yeah, okay. So so when client composite, right, creates these variables, right? Client composite is going to create these are the actual variables, like the reference types that we're creating. When we create them, it'll either be a number or it'll be a set, right? So, numbers and sets are set components. That's the first kind of relationship we have here, right? So numbers and sets are set components. Okay, so that's the first kind of abstraction that we have. Whatever. But then we have this idea here that a set, right, one set contains 0 or more set components, right? Like this set here contains 2 set components, right? And a set component is, again, either a number or a set itself, right? So this set contains 2 set components. This set contains 2 set components as well. Of course, it can have more than 2. But yeah, so that's essentially the abstraction. We have these, like, something is so numbers and sets are set components. Sets contain set components. And those are the 2 kinds of abstractions we have. Do you want me to explain that more? Or how do you feel about that? And then there's another question. When you call get component count, is it asking for the total number of components under it, or just the ones that are directly connected to it? Just the ones that are just the ones that are directly connected to it. Just the ones that are directly connected to it. Let's see maybe how she did in the lecture. Maybe I'm misinterpreting it. Let's see. I'll take a look quickly. Yeah, sounds good that you understood that. Maybe she didn't do it in the lecture. Somebody want to look? Because I don't want to spend too much time in silence here. Does somebody want to look in the lecture and see if she did it as, get component when she did the method get component count? If that includes, if that's like all of the, like if you said get component count on C1, should that return 2 or should that return, well, 1, 2, 3, 4? No, I'm 95% certain it's just 2. Like C1 has 2 components. If there were any instance variables in set component, would they have to be protected? If there are any instance variables in set component, let me look at set component. Set component like this. Well, set component, like why would you want to have an instance variable? Like I understand this, so maybe there's some application of it. Okay, so let's say each set had some sort of name. Like each set component has some sort of name. Then what would you say? I don't think they would have to be protected. Why would they have to be protected? I think they would. It could just be whatever. Yeah, I think it's just got the number of elements directly under it. Okay, so yes, so get component count is just the number of elements directly under it, which is what I have, which is like that is how it's implemented here. So it would only be 2. Yes, it would only be 2. That is correct. And then we have that. Okay. Can I try alternative 1? Yeah. So essentially, alternative 1. I haven't thought about that really. So let's try to think about it together here. What difference would I have to make in how I do alternative 1? So alternative 1 is removing it from here, right? So removing it from here. Let's go through it. Okay. Let's mess up the code a little bit and go through it. Did I close everything already? It's okay. Whatever. Oh no, I don't need government. I need everything except government. So client composite, set number. Okay. And I'll just close the rest of these. I don't care about these. There we go. This is being recorded. Let me make sure I'm recording. I am recording. Okay, good. But yes, this is being recorded. So why is this not moving now? It's not letting me. Like if I click projects, it covers the code. Okay, whatever. We're here now. So I want to try alternative 1. So the point of alternative 1 is that I remove these guys. Okay, from the abstract class. Keep clicking the wrong window. There we go. I remove them from the abstract class. So let me go to the abstract class, and I'll just comment them out. Oops, wrong slashes. Comment them out. Okay. So the abstract class only has the uniformly supported method. What that means now is in my number class, I have no need for any of this. Wrong slash again. Okay. And what that means now in set, why is set giving me an error? Override. There's no override. I'm not overriding anything anymore. Right? No point in saying override. Client composite, we have an issue. Okay, so I'll deal with that in a second. But these classes, all that's changed is I removed the abstract classes from the abstract methods, which are the child managing methods, from the abstract class. And so now number doesn't have to override anything, and set doesn't have to override anything either. It just has to give an actual concrete implementation. The thing is now, in my main method, this doesn't work anymore. I can't just say c1.addComponent c2. I have to specifically say c1 typecasted to a set add component c2. c1 typecasted to a set add component c2. Because add component is only a method that the set class has. Right? Oops. Set. So now when I run this, it should work. Still have an error for some reason. Why do I have an error? No, I don't have an error. I think it's just being weird. So I can run it, and it builds now, but I have to typecast the sets. Yes, I have to typecast the sets to sets, because only sets have the ability to do add components, not all set components. So all set components, you can't call add component on them anymore, only sets. So you have to manually declare them as, first of all, they are sets, but you have to actually change the reference variable, like typecast it to a set. Because again, that's the only ones that can have add component. But the issue with this is that now you're not treating sets and numbers uniformly, right? That's the thing. Like I'm not, like uniformly would mean that I just say C1 here, but now I have to specifically know that C1 is a set, and then I have to typecast it to that. This is for the first generic structure. This is number 1, I think. Yes, this is number 1. Let me find it. I don't know where I put it now. There we go. Generic structure 1. This is generic structure 1. I did it before generic structure 2. Where would you have to typecast? Right here. This is right in the main file. That's where I have to typecast. Right there. So this is, I did it before generic structure 2, but this is generic structure 1, and there we go. There's our explanation. Good question though. Yes, that's good to ask about generic structure 1, because we might have something similar. Just remember that if you're calling add component on a reference type, right, that reference type has to have that method supported, right? So C1, which is a set component, does not have add component supported. There is no add component method. Do you think they'll tell us what structure to use on the midterm? Maybe it's up to you. Maybe it's you have to tell them what structure to use. Maybe they put a question like that. I don't know. I honestly can't tell you. It could be either. They're essentially equivalent. It's just that with one of them you have to typecast, and with one of them it's a little bit less safe because you have these methods that don't do anything, and so the code might not work exactly how you expect it to. Right? These methods are weird, like they on purpose. Like they have to do nothing. Right? Why can't we declare C1 and C2 as sets instead of set components? Let me just see here. Because if I declared C2 as a set, so I could declare C1 as a set, that's fine. But I can't declare C2 as a set because only set components can go within sets. So if I declared C2 as a set, then I couldn't put C2 within this set. Because once again, only set components can go into sets. I could declare this one as a set because it's not going into anything. That's fine, right? Doesn't matter. But this one I could not declare as a set. And there we go. Yes, set component is abstract, so it can't be initialized, yes.